In the triangles unit, we learned a lot about the different properties that triangles have in relationship to their side lengths and their angle measures. The first thing we talked about was how we can classify a triangle. If we were looking at a triangle's angles, we could classify it one of four ways. If we noticed that all three angles in the triangle were less than 90 degrees, we called it an acute triangle. So maybe something like this, where you can tell that all of these angles are obviously less than 90 degrees. Then we had an obtuse angle, or obtuse triangle, and that's a triangle where you could tell that one of the angles is greater than 90 degrees. So start with an angle greater than 90 degrees, which clearly this one is, and add a third side. So here's a triangle with an angle greater than 90 degrees. Then we talked about right triangles. And those are triangles where they have one angle exactly equal to 90 degrees. And we would know that based on seeing the square there that depicts 90 degrees, or if it was a word problem, say it said triangle ABC is a right triangle, then we would know that was 90 degrees. And then finally you have an equiangular triangle. An equiangular triangle is a triangle with each angle being equal. And don't go by my picture, those clearly aren't, but just go by the arcs. Each angle is equal, and that equal measures of each 60 degrees. So this angle is 60, this angle is 60, and this angle is 60. And that's because the triangle has 180 degrees, and it was divided evenly amongst three angles, which gives us an angle measure of 60 degrees each. Then we talked about classifying triangles by their side lengths. And if we had a triangle without any markings on the side lengths, because maybe this side's 3, this side's 2, and this side's 6. The reason they don't mark the side lengths is because they don't mark them with congruency marks, is because no sides are congruent. So we call that scalene. Triangle with no sides that are the same. The next way we described a triangle by its sides was an isosceles triangle. An isosceles triangle is depicted with two markings, let's say here and here, which showed that two of the sides were congruent. And those sides that were congruent are called the legs. And the side that's not congruent to the other two is called the base. These are the base angles, and we knew those were also congruent. And up here, the angle that's not congruent to the base angles is called the vertex angle. And then finally, we name a triangle equilateral if all three sides are congruent. And if all three sides are congruent, then it's an equilateral triangle, and each angle is 60 degrees because each angle is congruent to the other. The triangle sum theorem. The triangle sum theorem, let's say we have a triangle ABC. If we add angle A to angle B to angle C, then we would get a sum of 180 degrees. Triangle sum theorem says the sum of the interior angles of a triangle, sum of the three interior angles of a triangle, equal 180 degrees. So if we're looking for a missing interior angle given two interior angles, so let's just say this is 45 and this is 60. Then the process you would do is to subtract the given angles from 180 degrees. So I would take 180 degrees, subtract the 60 because it's already been used, subtract the 45 because it's already been used, and I'm left with 75. Okay, let's say that I'm given an interior angle, 95, and an exterior angle, 110. Well, first thing I can do is to find the missing angles is to notice that these two angles here and here form a linear pair. So they have a sum of 180 degrees. So I would subtract this 110 from 180 degrees. So that would give me 70 degrees here. And now I have two angles of a triangle. So I would subtract those two angles, 95 and 70. I would subtract them from 180 degrees. So I take the 180 degrees and take away the 95. Take away the 95 because it's already been used. Take away the 70 because it's already been used. And I'm left with 15 degrees. Okay, now we're not always going to be given numbers to deal with. Sometimes we're going to have to use algebra to find the measures of a triangle, angles of a triangle. So let's say we're given a triangle ABC. And the measure of angle A, so A is twice the measure of angle B. And the measure of angle C is 8 more than B. So I take B and add 8 to it. What is the measure of each angle? So first let's start by labeling each angle with how we labeled it up here. So angle A is going to be 2 of B's. Angle C is going to be 8 more than B. Oops. It's going to be 8 more than B. And then of course we have just angle B. Now go back to your triangle sum theorem that says the sum of the three angles of a triangle, so 2B plus B plus 8 plus B, that's the sum of the three angles of a triangle, is 180 degrees. So I'm going to combine my like terms. 2B plus B is 3B, plus B is 4B, plus 8 equals 180 degrees. I would subtract 8 from both sides of my equation, and I get 4B equals 172. And I'm going to divide both sides of my equation by 4, so I get 43 is angle B. So I can replace each of these angles with their measures. Angle B is 43. Angle C is 8 plus B, which was 43, so 8 plus 43 is 51. And angle A is 2 times B, and we said B was 43. So angle A is 86. The triangle exterior angle theorem. Let's say that this is angle A, B, C. The triangle exterior angle theorem, we'll call this CD, says that the sum of the two remote interior angles, so the measure of angle A plus the measure of angle B, equals the exterior angle, measure of angle BCD. So the two interiors have a sum equal to the exterior. So if this angle, we'll go back to call this ABC again, and D over here. If this angle A is 30 and this angle B is 45, to find the exterior angle, we would take the sum, 30 plus 45, the sum of the two remote interior, and that would equal the exterior. So this exterior angle is 75 degrees. So let's say, ABC again, let's say we want to find the interior angle given an exterior, so let's give an exterior angle and an interior angle. We'll come down here and call this 30. So we don't have a variable designated for angle B, so we're going to look for angle B. So what we can do is use the exterior angle theorem to say the sum of the two remote interiors, so measure of angle A plus the measure of angle B equals the exterior angle, 110. And measure of angle A is 30. Measure of angle B, we'll just call it B. That equals 110. So we would really just have to subtract the given interior from the exterior in order to find the other interior. So 110 minus 30 is 80 degrees. And then of course to find this missing angle C here, we have a linear pair. So 180 minus 110 is 70 here. Okay, the triangle inequality theorem says that the sum of the two smallest sides of a triangle must be greater than the third side. So let's call this triangle ABC. Let's say that AB is 10, BC is 5, and AC is 11. So in order to know if this exists as a triangle, we have to add the two smallest sides. So that's 10 and 5. So the two smallest sides, they must have a sum greater than the third side. And since 15 is greater than 11, then this is a possible triangle. So down here, can the following be the sides of a triangle? We take the sum of the two smallest sides, 8 and 9. The sum of the two smallest sides must be greater than the third side, 16. So 8 plus 9 is 17, and that is greater than 16. So yes, this can make up the sides of a triangle. So once again, we have the sum of the two smallest sides, 8 and 10, must be greater than the third side, 18. 8 plus 10 is not greater than 18 because 18 is the same as 18. So no, this does not make the sides of a triangle. And then finally, what if we want to find the range for the third side of a triangle, given two sides already? Well, if these are the two sides we were given, and we're looking for the third side possible value, remember, the third side, we'll call it x, has to be greater than the difference of the two given sides and less than the sum of the two given sides. So we take the two given sides and subtract them from each other, and we take the two given sides and add them together. So 54 minus 7 is 47. The third side must be greater than 47 and less than 54 plus 7, which is 61. So the process behind this is to add the two smallest, or the two given, and subtract the two given. And the third side must fall anywhere in between those two sides.